In CodeStrike, our mission-based shooter, a single broken link can stop player progression dead in its tracks. To solve this, I worked on the Mission Validator, a comprehensive tool that automates QA for the entire project. The tool runs a series of 9 specialized validation modules in sequence. Here is exactly how it validates our game, component by component. First, the system runs collider tests. In a shooter, bullet penetration and cover are critical. This module scans every trigger in the scene to ensure it's on the correct ignore raycast layer so it doesn't block shots. It also validates our cover system, ensuring every object marked as cover actually has the required cover node script attached, preventing AI from trying to hide behind broken geometry. Next is the core logic check. Objective mission tests. This validates the quest data itself. It enforces strict rules on XP and coin rewards to ensure game balance. Crucially, it checks for event symmetry. If a mission enables an object when it starts, the tool verifies that completing the mission correctly disables it. This prevents soft locks where quest items get stuck in the scene. It also validates cross-scene references for our placeholder missions. Third is the dialogue content tests. Our game relies heavily on narrative, so this checks that every dialogue object matches our strict prefab standards, whether it's an earpiece message or a cinematic face-to-face conversation. It validates that our salsa lip sync components are hooked up correctly, and enforces naming conventions on audio clips, ensuring the right voice lines play for the right character. Fourth is the UnityEvent Validator, one of the most powerful parts of the tool. It uses reflection to deep scan every Unity event in the scene, even those hidden inside nested components. It flags disabled events that are set to off and identifies broken references where a designer might have deleted a target object. It essentially catches logic bugs that would otherwise be invisible until runtime. Next, we run the Missing Link Validator. This is a rapid-fire sanity check. It scans all game objects for missing scripts or null object references in serialized fields. It's a simple check, but it catches the most common errors, like when a script is removed from the project but still referenced in a scene prefab. Sixth is the MISC Objects Validator. This handles our interactive gameplay elements. It verifies that every door has a NavMesh obstacle, so enemies don't walk through them when closed. It also checks our hacking minigames, ensuring the UI Access tab matches the logic on the hackable object. For example, guaranteeing they both require the same security clearance level. Seventh is the props test, which acts like an automated technical artist. It scans the scene for optimization issues, flagging high-poly meshes that are missing LOD groups. It also enforces our layering system, ensuring small props are on the small layer and medium ones on medium to optimize culling. If it finds issues, we use the helper tools to auto-fix the layers and flags. Eighth is the Emerald NPC Validator. For our AI, this tool raycasts to ensure every enemy is actually standing on a valid, baked NavMesh. It also checks the hierarchy, ensuring NPCs are parented to our distance culling managers for performance, and verifies that their faction ID hasn't accidentally drifted from the prefab default. Finally, we have the Sector Validator. This manages our level streaming logic. It checks our directional triggers to ensure symmetry. If entering a zone loads a sector, exiting it must unload it. It guarantees we don't have memory leaks or invisible geometry blocking the player. By automating these 9 stages of validation, we ensure CodeStrike is stable and bug-free with every build. Thanks for watching.